Good afternoon. Thanks for sticking around. I know it's. I heard some people saying, "Oh, it's the end of the conference and so on." So I just got here, so I'm glad you stayed around for my talk. Let's get to it because we only have 15 minutes, unfortunately, or fortunately, maybe for you. My name is Cristian. I work at CERN. It's this nice little 27-kilometer ring where we collide particles. I used to do a lot of work around computer security on SSO. Now I work in something called business computing. But yes, if you ever pass by, I can probably take you underground. Feel free to take my details from the last slide. This probably motivates you to stay until the end of the talk, at least, right? Good. So this is CERN. It's an amazing place where at the core of each detector, every 25 nanoseconds when the machine is on, we collide protons, right? Unfortunately, we're going to be talking about more mundane stuff today, right? More earthly things like single sign-on, right? You're probably here because you care about Spring security. You're probably here because you're facing some interesting challenges in the work that you're doing. I hope that we can together, try to solve these things, or maybe try to find some interesting answers to questions that you might have had. If you missed the last episode, this is kind of a joke, of course, maybe you weren't around, but last year I was giving a talk called Identity Crisis, Spring Security Patterns for the muggles, let's say. It was talking a bit more about what you do inside one Spring application, right? So OIDC, OAuth, resource server, OAuth client, when to use them, and so on. What type of flow to use, and so on and so forth, and some more advanced use cases, right? There's a YouTube link at the bottom there if you want to watch it at some point in the future. If not, that's fine. You don't need to know anything. It won't be on the test, so it's all good. Now, you got past having a Spring service, right? It's in production or whatever. You're super happy. Things are ramping up, right? But the team is growing. The business is growing. The software, whatever you're doing, is growing, right? And you need to scale to multiple services, to multiple application servers, and so on. So I want to give you some tips and tricks, which basically will help you get the best AuthN, AuthZ experience that you can get out of the box using Spring. And we consider Spring security in a single service as a solved problem. Now, how do we actually manage to look at the bigger picture, right? You came at the talk, which contains architecture in the slides, right? In the title even. So be prepared for diagrams, right? Diagrams will be around. Now, we're going to split this into 4 big topics with some code in between to kind of discuss the concepts at hand, right? So first, we're going to be talking just about scaling and what the pain points might be, right? When you start growing your applications to a large organization, for example. Then we're going to be talking about multi-IdP federation concepts, AuthN, AuthZ patterns to use with those things. And finally, we're going to be talking about gateways and integration patterns that we would like to use together with Spring Boot, right? You can stop me at any time and ask questions if you really need to. Otherwise, I will try to leave some time at the end. Now, let's look at the ideal picture, right? So trouble in paradise, I like to call this slide. You're very happy, right? You have an application, you have one user. That user goes to your application, and they want to talk to the SSO. They put their credentials in, they log in. Perfection, right? Everyone is happy, everything works just perfectly, right? Until you start adding more things, right? And then your image starts looking a bit more like that, right? So there's a bunch of things. Let's consider green servers that do authorization for you, so small applications, microservices if you want to call them, and so on. Red, maybe things that do authentication for you, right? You might have multiple IdPs, identity providers, right? So in this situation, I just put Keycloak, Google, whatever social credentials you might think about using in your applications, right? And it quickly becomes a mess. And at some point, you might find yourself in a situation where you're in the server room and you're looking at all this spaghetti and kind of not understanding what's going on, right? This is why you came to the talk, probably, to figure out how not to get to that situation, right? Or maybe to try to get some insights from me that could actually help you go on the right path, right? Now, one thing to look for maybe in your applications and so on is if you have multiple services deployed or running wherever, if you look at them and each of them does its own thing, right? So maybe the roles look differently, maybe the structure of the JWT token that you get looks differently in each of them, right? That's maybe the time to start worrying, right? If each service does its own thing and you don't have kind of like a common way of doing everything, you're probably on the path to burning down and crying, right? So let's first talk a bit about some higher-level concepts, and then we'll get into like the Spring code, right? So multi-IdP federation, very fancy concept, but the whole idea is the following. I have here 3 possible scenarios that you might have when you want to set up multiple identity providers. So imagine you want to add Facebook, Google, and your own enterprise SSO, auth0, I don't know, or Keycloak or whatever that you host locally, and you want to let people authenticate through each of them, right? You have 3 options. The first one is your application is a client which is multi-tenant, right? Meaning that when you access your application, you're going to see a couple of options there in your Spring settings, right? Saying, okay, I want to log in with this option or that option or that option, right? That's an easy way of doing it, right? It's just you need to kind of have some sort of custom code going on there and so on. The second option is IdP brokering. So basically, instead of having to do all this complex configuration inside the code, what you can do is kind of, let's say, outsource this to your identity provider, right? So your identity provider can be the one which knows, you can log in with Google, for example, but then you get redirected back to the IdP, and the IdP does some magic there to kind of align all the token information to what you're expecting in your organization, right? This is usually the most sane solution and the one that I would recommend. And the third one is in the case of APIs, for example, right? So your user in this situation would be an API, right? So the API wants to talk to a service, my app in this situation, right? But they can get tokens, they can get credentials from multiple providers, right? So they can get the token for your Facebook application, Google Auth, internal Auth server, and so on, right? And the only difference between them is like a couple of claims inside the token and maybe some keys, right? Now, then your application needs to do the heavy lifting. So that's why I would definitely recommend trying to do the second thing, right? But we're going to go through how to do each of these setups, right, by yourself, right? So the first one, actually before that, I wanted to show you an example of the second thing that I'm suggesting. It's a bit eat your own dog food. So this is the CERN single sign-on page, right? So if you look on the side over there, you have a bunch of options with signing in with different organizations, right? So you can use your email address just with like a lightweight account, as we call it, or you can use GitHub, LinkedIn, Facebook, Google. You can also use Edugain, which is like a university system, so you can log in through your university's SSO and then get redirected to CERN. And all of the heavy lifting in between codes is done by Keycloak. So in the end, the JWT token that you get will look very, very similar regardless of what service you use to log in, right? But then you can check the roles that might differ and so on depending on the IdP that you used, the underlying IdP that you used. Don't worry if it's confusing. We're going to get to the examples, and when I start touching things, then you might get it more easily. So how to set up multi-tenant clients, right? So when you go to your Spring application and you see the screen with multiple options, well, this is easy. You can just add a couple of them or even more. Here I have them highlighted. So I have my app and federation tests, which are 2 different clients that belong to different realms in Keycloak. So basically in this situation, I have Keycloak configured with multiple, let's say, IdPs inside of itself. And then you need to override one of these classes in Spring Security called auth2 authorization request resolve, or actually you need to implement it, right? So once you do that, then you can actually say, oh, this request is for login. For which kind of application is it, that or that, right? And depending on the server that you choose, you can log in with one set of users or the other in your application, right? Another option is the multi-tenant resource server. We're not going to go a lot into detail with this one because it's basically just a bunch of configuration that you can do with Spring Security. But the whole point there is that you can implement a bean called Authentication Manager Resolver, and basically it's the same thing. So you can see this, this lambda which is being returned. It says request and then use jot of request. So are we using jot? Yes. Then I would use that provider. Otherwise, I would use the opaque token one, which we're going to get to in a second. There's plenty of documentation on how to do that, so you can follow it and kind of try to do the setup by yourselves. And then there's the IdP brokering that I was talking about, which is basically there's no real code involved, really. It's just a bunch of configuration that you do yourself in your servers, right? So here's an example of the Keycloak identity provider setup page. So you can make Keycloak talk to itself, to another realm living inside Keycloak, and then you can use that to your advantage to isolate users or use users that have different rights and permissions and so on. One thing before we get into the code is to think about token normalization. So try as much as possible to have flexible authentication, meaning you can log in with whatever you want, but to have tokens which look very similar to each other. In this situation, I have a Keycloak token on the left side. This is a deserialized jot, right? And you can see the highlighted part there. So roles, normal user, right? But it's in a nested JSON object, right? Meanwhile, on the right side, I have an Azure token, which just contains roles and then an array, right? So you can see that they don't match with each other. That's a big issue, especially when you need to implement, I don't know, 5 of them, right? So then it gets really interesting. As long as you set up your IdP correctly, you can get away with all of this madness by just making sure that the tokens look alike, right? You need to figure out in your organization how they should look like, but they should be normalized. That's why I think this is an important thing to communicate. Okay, so let me show you really quickly what I mean. Now, I have a bunch of things here for you, but the most important part is here. So I have 4 projects, but we're only going to be talking about 3 of them. So I have a gateway, which we touch on later. I have an auth client, and I have a resource server. So the auth client is super simple. If I go into my application YAML here, it's just an application which connects to, well, to the database. And then I have a registration here, right? So how does that look like? Well, if I go to my local machine, I have Keycloak running here, right? So I log in, and I have a couple of different realms here set up. So the app realm is the one where I have an application registered called my app, and I will be using my app as a demo from here on, right? So my app is the app we're logging into. And in users here, you can see that we have Alice, Bob, and Jim. Okay, we're going to get to that in a second. But basically, Alice and Bob are the only ones which I can actually use to log in to my app through the app application. That's good. And, well, the password is the username, just to, in case you want to explore the code in the future and play around with it yourself. Now, my beautiful application here, it's running on port 8081, this OAuth client application, right? So if I go to 8081, I get the beautiful default Keycloak sign-in screen, which says, okay, username, email. So if I log in as Bob, with Bob as credentials, voila, amazing. So I'm logged in as Bob. I have some scopes, some roles, whatever, things that come in the token. This is basically the deserialized token that you see here. What's interesting to see in it, maybe the audience, my app, and so on, right? Okay. Well, as you have seen, I didn't really have the choice of choosing between multiple providers. So, because this thing here only contains the security configuration for one identity provider, right? However, if I run it with the federated profile, inside the federated profile, I have 2 IdPs configured, right? So I have Keycloak and federation, which talks to another thing. Don't worry about this. It's all safe. It's just something running locally. Don't try to hack me. So if I run my federated application now, try to log in, maybe I should kill my, yeah. All right, so now we can see that I have two options, right? So I can log in with my federated realm or with app, right? Imagine here whatever social credential you might have, right? And the magic sauce behind it is, well, it's this, but it's also the fact that once I log in, then I have this beautiful custom auth to resolver here. Second. Can you see the code, or do you want me? Yeah, it's good. Okay, I won't zoom in. So basically here I check the moment the request comes with this resolve method being called. Basically, you need to delegate to one or the other authentication providers that you have configured here in your federation, right? We don't need to jump really deeply into it, but basically this is more or less how it works. And then if I click on federated, and I try to log in as Bob, well, Bob doesn't exist, right? So there's only Bob and Alice defined in my main app realm. And in this realm, over here in the federated realm, I have Jim, right? So that's why I said that Jim won't work to log in into the main my app realm, right? So if I log in here with Jim, okay, amazing. Now, this might look the same, but it's not. Why? There's a very important claim in JOT tokens here. It's ISS, issuer, right? So who issued this token? So in this situation, it's realms federated. And you'll see what happens if I try to log in through a federated realm and call any downstream server that I might be calling. It will fail. But why will it fail? Because it's looking for my app registration, not this thing, right? So let me just show it again. So I'm logged into the federated realm right now, but the token will never work in anything which expects my app token to arrive, right? So when I log in as here, and I log in as Bob, I get issuer realms app, right? And this token can be used to call anything that expects that issuer, right? So multi-tenancy, if you try to do it like this, it's going to be a kind of difficult issue because you have your clients, which are multi-tenant, but then also your servers need to be implemented in a multi-tenant way, meaning they need to process tokens that correspond to each of the identity providers that you allow people to log in with, right? This is not federation. It's just multi-tenancy, right? We're going to get to federation in a second. Now, AuthN and AuthZ. So we're going to look at two different things. So what can I do with my tokens once I get them from the SSO? Then maybe how to set up my centralized login services and per service / per domain authorization. So just to keep it clear with everyone, so AuthN means authentication, right? So who am I? And that's a concern of the IdP. And AuthZ is like, what am I allowed to do in my application, right? So it's a service domain. It's a service concern. It's a domain concern. Now, for the token, you have two options. So let's take the first option here. So this is the edge validation. Actually, no, this is the downstream validation pattern, let's call it. So you log into your IdP, you get the token back. You use that token to call an application, and that application will be calling other services downstream, right? What it does, it just takes your JOT token and it sends it down, right, to the other API. Same JOT, right? This is great because, well, you can just use it to any kind of service that you want, right? So you can just add 1 million services and all of them will accept this given the right configuration. The problem is you kind of need to duplicate that configuration across all the services that accept this token. Another option is the following. You get the JOT token and you send it to some sort of, let's call it a gateway, that will transform or exchange your token into something opaque. So opaque token here basically just means a string. It's just a string which is uniquely identified. It can be a UUID. We're going to see in the implementation how it works. And that opaque token is then sent down to any service that might be interested, right? So authorization, bearer, and then that piece of string, not a JOT token, right? The service receives it, and then they don't know anything about who they are, right? Because it's an opaque token, it doesn't contain anything. So there's this RFC called, RFC 7662. It's OAuth2 token introspection. If you want to know anything about yourself, you need to know who to call, right? So you just have kind of like a pointer to your identity, and you ask another server, this introspection endpoint that you see at the bottom there, to tell you who you are. Why would you ever do this? Well, there are a few advantages, actually. So JOT is everywhere, right? Everyone uses these kind of tokens. They're amazing. They're decentralized, so every single service that you use can validate itself the fact that the token is valid, right? By checking the public key that comes together with the token, right? However, and there's not a lot of moving parts, right? You can do all the validation by yourself in an isolated manner. However, there are a lot of cons that must be considered as well for certain situations. So, for example, when you parse the token, if your claims are nested somewhere inside, either you have a library which you share across all the services, and then basically you handle these IdP quirks, as I call them in between quotes, in each service. Then you also have token bloat, right? So you may want to pass the roles that are available to all the services in your company, right? Maybe you have 50 or so, and maybe you have 50 sets of roles that you pass into that token. Imagine how big that JOT token would look like, right? Then, if you leak it, you might say, oh, but I mean, JOTs are public information. Well, yes and no. Lots of people put email addresses in JOTs, right? So if some evil attacker picks your token from your browser, then they're going to have your email address just freely readable out there, right? So maybe in some situations you don't want that. And to me, one of the biggest deal breakers is the fact that it's not easy to revoke. So once you generate a JOT, it's self-contained. It's valid for as long as it says it's valid. And you can't do anything about it. So if, for whatever reason, some malicious person takes your token and starts flinging it around and doing things with it, API calls, it's really hard to actually stop them, right? Unless you, I don't know, block their account and all that. However, it's up to the implementing service to choose what they do with the JOT token, right? Because if they don't revalidate, because, for example, with Keycloak and other IdPs, you can't take the JOT token and send it to the introspect endpoint, right? It's totally fine, and then it will say, yeah, it's valid, it's good, it's perfect, or not. But if you don't, and you just locally validate these tokens, then you're kind of screwed, right? You can't really do anything until the token goes away. Given the fact that some tokens can be very long-lasting, because, I don't know, you have jobs which run for hours and so on, the attack surface can be huge, right? Comes in the opaque token, which is very easy to revoke. Why? Because every time you need to get information about who you are, let's say for every request, or you may cache it, but only for a short amount of time, you call some central authorization service which knows about this thing, right? They give you back some data. They can also give you back dynamic roles, which is kind of cool, right? So maybe it's time-based, maybe it's, I don't know, there are multiple ways of implementing it, but basically the moment you send the token, if you send it again, you might get something else back, because it's just logic that you can put in your code, right? And then, of course, it's very easy to set it up because you have uniform handling. You're going to see the code in a second, but it's super easy to do it. The cons are, of course, centralization, right? So if the gateway goes down, everything goes down as well. There are more things that can break, and it's also harder to debug, right? If you don't have proper observability or whatever set up, then it's going to be really, really hard to figure out why that particular service isn't running as it should. Now, moving a bit to the side from that, very briefly covering the backend for frontend. This is a very nice pattern because if you have an API that you want to call from your single page application, your single-page application can do the authorization, the authentication, I'm sorry. So you can just talk to the IDP and say, please log me in. Fine. You're logged in, you get the token, but again, it's in your browser. Like I said, maybe you don't want to leak all that sensitive information or that huge token in every kind of request that you do to an API, right? So instead of doing that, you just add another backend, which is called the backend for frontend, in front of your single-page application and your API, right? And that one will be doing the authorization code, login process, and so on. And that's super nice because you just use a cookie, right, which is easy to invalidate even from the server side. And you use that for the session of the user, right, for the calls that the user does. So it really minimizes a lot the, let's say, attack surface that you might have in case you're dealing with single-page applications. And then lastly, one interesting thing that you can do is per-service authorization, right? If you're using opaque tokens, nobody says that you need to have only one authorization server. You can have authorization servers per domain, right? So in this example here, we have an invoicing service, which basically receives opaque tokens and gives you back the roles that you have for invoicing, right? Then you have an HR authorization service, which gives you some information about what you're allowed to read about people, for example, right? And the examples can continue like that, and that means you don't bloat one huge service which does everything. You don't have a God authorization service. You can split things by domain and go with domain-driven design, whatever kind of architecture you guys want, and so on. But it's very nice because it keeps things readable. It keeps things manageable, right? Of course, you have the overhead of deploying more things, but you're probably already at that point if you're in the talk, right? Because otherwise you wouldn't be here. Cool. Let's have a quick look at all these concepts that I was talking about. So the first one, just one small thing. Don't have this Zoom thingy. All right. So we're going to be looking at my yes. We're going to be looking at the gateway. So the gateway itself is quite a simple application. It's using Spring Cloud. So what we have here is just a bunch of configuration, which doesn't really do a lot, let's say, in this case. We just have an issuer URI, which is basically validating the JWT tokens that arrive from the app realm. And then we have two downstream services. One is a JWT service, and one is an opaque token service, right? And the way things are configured, it's quite easy. So let's look at the configuration of one of them. So in here, well, I have a bunch of things, but basically what we're interested in is this. So when a token comes in your application in general, if you implement a converter of something to abstract authentication token, then if you have a bean which implements that, then basically you can do whatever you want and build your own, let's say, principle before it actually reaches your application, right? So in this situation, I have two. I have JWT authentication converter, which is used when we're spawning the JWT service, and I have an opaque token authentication converter, which is basically the one that just gets data from the auth to authenticated principal here, right? Quickly, yeah. So when a call comes, let me just 1 second. I'm trying to figure out if maybe we go and I show you some more, and then maybe I can show you this part first. So this is the setup. This is the whole setup that we're looking at right now, right? So we have one service, one application that is just using auth client. Through that application, I log in to one or more IdPs using federation. Then I send my token down to a gateway. Based on the endpoint that I call, which is it's just using Spring Cloud. It goes either to resource server 1, which is a JOT validation server, or to resource server 2, which takes opaque tokens in. And there's a cache somewhere in the API gateway. It also acts as a service for introspection, right? Just to get things clear. For opaque tokens, it's very simple, right? You send the JOT, the service converts it to opaque token, and sends it down. And once it gets down into the authorization layer, authentication layer, let's say, of service A, it's going to call back the gateway to introspect, see what's inside the token, right? What kind of information do you have about me? And just to zoom in a bit more into the gateway, once the JOT gets converted to an opaque token, it gets put into a cache. That cache is then used for subsequent calls so that you don't need to generate a token every single time, right? And you send it down. Once it goes down, the RFC says that you use basic auth. So you have a client ID and client secret in each of your services that use opaque tokens. And for those for those purposes, you just send them through to the introspect endpoint, right? Once it reaches the introspect endpoint, it builds a payload and it sends it back to you. It looks a lot like a JOT token, but it doesn't need to contain all the fields that you might see in a JOT. Okay, so let's have a quick look at everything running at once. So I have here the resource server that uses opaque tokens, the resource server that uses JOT tokens, the federated auth client application, and the gateway itself, right? No breakpoints yet, just to see how it looks like. So when I log in, okay, I just want to log in through app. Why? Because federation is actually done at the level of my IdP. So if I want to log in as Jim, as I was showing him before, I can do this through Keycloak. I don't need to do it through my OAuth application in this case. Both are set up, but there's a subtle difference. When I log in through federation as Jim, the issuer here is the app realm, right? So that means basically that I can use this token for anything that the app authorization services expect, right? And then I call the gateway. So I call both places at once. Let me get to that part of the code. Here we go. So what I inject here is the authentication token, so the current token, like who the logged in user is and so on. I can see it in the logs here. It says the logged in user is Jim, and then the auth is like this token that you saw printed out in the page. Then I check which is the client which is authorized, because I have multiple ones, right? And I get the access token. So this is just the token that I then pass down to the gateway, the JOT in this situation, right? Because we know it's a JOT. We send it down to API JOT hello roles and to API opaque hello roles. And we just display them. So from a functional point of view, we can see that basically, well, Jim doesn't have any roles, because this one also shows the scopes, but there's nothing with role underscore whatever. Jim is not the greatest example. We have Alice for that, because Alice also has a couple of roles in the main app. So if I log in as Alice here, voila. Now, you can see that token type JOT, this is at the bottom of the call, right? Like when it gets all the way down. We have role admin, role normal user. Okay, perfect. And in the other one, we also have role admin, role normal user. Now, how does that work? When the gateway gets called through this gateway application, it has a couple of routes configured. So these are routes from Spring Boot Cloud MVC, right? So this is using MVC, it's not using Webflux or whatever, because it's easier to reason about it. And there's this nice DSL, right? So we know that the downstream of the JOT service is 9001. The downstream of the opaque service is 9002, right? So we just basically check that we're calling API jot la la la. And when that happens, we just call the jot URI. Simple, right? It's pass-through. We just send the jot token down to the next services. With the opaque token, it's a bit of a different story. Before we actually pass it down, we need to do something. We need to build the opaque token, right? Because we never showed that part yet. So for that, we can actually implement a filter, which is, in this situation, in Spring Boot Cloud, it's handler filter function, right? Which takes, it takes the request and then basically it applies some stuff to it, right? We implement this filter method. We take the principal. So basically, we take the token from. We can even put a breakpoint here to see how it looks like. All right. Okay. So. The principle in this situation is my jot authentication token, right? Well, it's an optional, right? Then we basically do some sanity checks for this jot token. So is it, if it's not an authentication object, then we go away. If it's not a jot authentication token, then we go away. Then, once we get the jot token from, well, basically just getting the token here, we have the value itself, which very nicely with IntelliJ, you can actually see the contents without needing to go through anything else, right? So I can see here what my roles are and so on and so forth. We generate the opaque token. The opaque token in this situation is just a UUID, right? So just this, okay, perfect. And what do? We basically, we build our own version of a token that's stored with a TTL. So we just store things in a cache. You can imagine, well, in this case, it's just an in-memory cache, but you can imagine it being Redis or whatever, right? That Redis instance will be storing your, well, your information, your credentials. And then we mutate the request. We get rid of the former authorization header, and we put better opaque token in the authorization header of the next request, right? That goes down to our services, right? So that's awesome. But then what happens? Well, we can actually go and debug our opaque token service here. The implementation is super easy because with Spring Boot, you just need to define this. So basically, if there's something defined, then basically we use an opaque token authentication for auth to resource server, right? And this one uses an authorities converter just because I want to be able to parse things in a similar way to what I do with my jot to get the roles out of it, right? Because they're nested and so on. So this part of code here is not very relevant. It just basically takes all the roles out of my nested object and then it puts them into my bearer token authentication. So basically the object which contains all the information that I got by calling the opaque authorities introspection, right? So if I can put a breakpoint here, but I can also put a breakpoint in introspect here. This is in the gateway, right? So we're at the point, we're here, right? So we're at the point where we're basically rewriting the authorization header and we're sending it down to the opaque token service, let's call it, right? I continue this. Awesome. So what happened? The token went down to my opaque, the opaque token went down to my resource server, which uses opaque token authentication, but that one doesn't know what to do with it, right? So it sends it back to the gateway, to this introspect endpoint, which expects, basic auth, in this case, it's just like an in-memory user with a fake client ID and client secret, but you will probably secure it with something better. And we get the token. So it's the C7 la la la, right? Which basically is what I showed you before. It's the entry that got stored in the cache, right? So one very important claim that needs to come back from the introspect endpoint is active. So active needs to say true or false. If it says false, for example, if you revoke it, then it's done. Then you're not authorized to do anything anymore, and the request ends there. If it's set to, well, in this situation, we just we look up for the token that we stored, and there's nothing. And it blows up. Okay. Why is there nothing? Maybe I talked for like 5 minutes. Okay. Demo effect. Well, anyway, so Bob. Okay, yeah, cool. Magic restart. So we get the stored token, which is basically just a record that I defined on my side. We know when it expires, and then we have all the attributes from the JOT. So basically, I just copied over the attributes from the JOT. The world is your oyster here, right? You can just like implement whatever you want here. You can do anything you want and design your own tokens to match your expectations. And once the token comes back, we put active true in the response, which is just like a hash map that we're returning, and then a bunch of other claims which might be useful. And then we also put like a token type opaque. This is just as an example that you don't need to follow a certain schema. You can put whatever you want in these tokens, right? And then it gets back. This is at the resource server level. When the claims come back, I can also do my own parsing of these claims to make sure that I get the roles and everything that I need inside an isotl object here. So for example, I'm collecting all the authorities. So you can see here that I have role normal user and a couple of scopes as well, right? So basically, in this converter here, I'm just taking whatever comes from the principal and saying, yeah, I mean, it's cool, but I don't really like these attributes like that. I actually want to insert them into something that then I can use, for example, in my pre-authorized annotation saying has role normal user or admin or whatever, right? So this ties in very well with the authorization part of Spring Boot. And it's up to you in your service to figure out what you want to search for, right? But that's the whole flow, basically. And what we see here is the response from the downstream service, not from the gateway itself, that got proxied from the gateway, with all the authorities that are in my token, right? So in this situation, normal user and normal user in both tokens. Like I said, if I invalidate this one, then suddenly we get the 401 or 403. And this one, we can't really do anything about it, right? So if I just reuse the same token, it's going to still work for the duration of the token, which is 5 minutes, I think, because it was 12, and this is 17 for the expiration. Right. Last few words. A couple of takeaways. So one of them is token choice is really important, especially if you're building a big system. JWT everywhere, so JOT everywhere could work, but there are other options as well, depending on your use cases. Opaque tokens are great for sensitive environments, like I was saying. If you do a banking transaction or whatever, and you need to immediately revoke that thing because you already did the payment, for example, and you don't want to be able to repeat the same payment twice. Or hybrid. So hybrid is the most common one. It's the one that I was showing you. So basically, we get the JOT at the level of the user, or let's say the surface level APIs. Everything else which is internal is going to be using opaque tokens, which makes life easier for everyone. There are a couple of pitfalls as well. Make sure to set sensible TTLs, right? So time to live metrics, basically. You shouldn't be putting 3 hours, 5 hours lifetimes on tokens. Tokens in general should be cheap to create, right? So try to use something sensible. Gateways are a single point of failure unless you replicate them in multiple ways. And lastly, of course, make sure you take care of observability and auditing and so on, but this is available in every kind of distributed environment, but this one in particular because it's also related to security, right? So you need to be able to tell why Alice managed to access that endpoint whenever, I don't know, the auditors come, right? Okay, if you have any questions, there are a couple of minutes left, actually. I put there the slides and the code as well. It's on a branch, actually, in that repository, but you're going to figure it out by yourselves. If you want to connect with me, feel free. There's also an email address if you're more old school. And that's kind of it. So thank you very much. You have a couple of minutes to ask me questions. Thank you. Yes? Right. So the question was if the gateway is always responsible for exchanging the JOT to an opaque token. You can use something else as well. It doesn't necessarily matter. You can. The thing is, it will go through the gateway anyway, right? Because the gateway does the routing finally, but you can talk to another service, get back your opaque token, and send it down. So the opaque token service and the JOT service, they don't need to be the same thing. Yeah. We have 2 minutes for questions if anybody else. Yeah? You have a microphone there.
All right, okay. I got another question. Have you ever encountered a course problematic with a single page application?
Could you repeat, please?
Have you ever encountered a course problematic?
Course problem with single page apps. Yeah. Yeah, definitely.
Yeah, how do you handle that? For example, you have a single page application that's protected, and you use an authorization code flow. And the first time you fetch this single page application, everything goes okay because it's a normal HTTP. But after, when the HTTP session is timed out, it's invalid, the server, the REST API, will respond with 302 redirect.
Right.
Then it will be the JavaScript in the single page application that will receive this. Do you have any good pattern or?
Yeah, so basically, this gets rid of most course issues actually. So if you use a backend for your front end, then you're kind of you're always in the same domain. It's like you're always calling localhost from your front end, right? Unless you need to call a lot of different services, right? But the idea is that you have one service which proxies all of the other requests to other services that you might have, and it's a very clean way of doing it like that. So if you can avoid calling the API directly from with authorization better, because that's the issue of the course issue, the course problems. You have a domain and you're calling something which doesn't allow you to call from that domain.
But then you need to build this, and every backend need to build this. Is there a generic solution or?
A generic solution. You disable course, but yeah. Unfortunately, no. Course is a hard problem by itself because it's made for browsers, right? Yeah. Once you get past the browser and you're at the API level, you don't have course issues anymore because you can just talk to anything that you want. So yeah, thanks. Backend for frontend. Well, thank you.